Now we are going to demonstrate how to calculate the variance and standard deviation for a raw set of numbers by using the second formula. Let's call it method number 2. Bear in mind, variance and standard deviation, what it does, it gives you an idea as to how different the numbers are, how spread out they are, okay? The differences amongst them. That's why it comes with a subtraction sign and you have the mean involved. So the mean is a central number, a descriptive number to describe the average. But no, you might not be interested in the average of those numbers. You might be interested in how different they are, okay? The differences among them, how clustered or how dispersed they are. So that you can, to do that, to analyze the differences, there's a descriptive measure called the variance and standard deviation, okay? And there are 2 methods. So we're going to apply method number 2. Let's look at the formula for method number 2. Variance is equal to the sum of x squared divided by the number of values minus the square of the mean of the values, the data values. So we know the mean of the data values already. We used it in the previous method. So let's carry it forward. It was 78.83. Here it is. So let's carry it again. So bear in mind, to calculate the variance and standard deviation, you need the central number first. And from that, differences now, the relative differences are calculated, and this will give us an idea as to how different the numbers are. 78.83. And also we know how many is 78.83. So we have to square it according to this formula. And we know n is 12. Okay, look, 12 right there. N is 12. All right. So therefore now what we're missing to calculate is this number there, the sum of x squared. But we have to take note that anytime we see sigma, we have to do whatever is to the right of sigma first. Okay. Always remind ourselves of that. And this can be easily done using tables. Okay. So when we scrutinize this formula, here is sigma, and sigma now is telling us we have to sum x squared. So we must do x squared first before we sum. We must do the x squared first before we sum. So let's go back to our faithful Excel. All right. Let's undo this. Pop, pop, pop. Okay. Undo this, right? And our heading is x squared. X squared. So we have to square the x. Okay, remember that's what the formula says. Square the x's and then sum. Another way to look at sigma, whenever you see sigma, start on the right. In mathematics, you can read from left to right, or you can read from right to left. Familiarize yourself to reading from right to left. Whenever you see sigma, start on the right. See sigma, I will do you last. I'm starting to do that first, and after I do that, I have to add, because you need to do things before you add. You cannot add one number by itself. What is the sum of the number 10? What is the sum of the number 3, for example? What is the sum of the number 12? If you have one number, can you sum one number? You need at least 2 numbers to find their sum, you see? So we have to do all of that and to find the sum. And what is all of that? Squaring, multiplying each number by itself. So in your calculator, you have to do this manually. You say 57 times 57 equal 342.49. You write, put the 342.49 and then write 60 times 60 equal, okay? But you have Excel, so you just type equal 57 raised to the power of 2. Enter, bam. But if I type 57 all squared and I double click the green rectangle, Excel will just repeat 57 squared for me. So I want to communicate to Excel now. I want to do this for each of the values. So I have to tell Excel now equal A2 squared. A2 raised to the power of 2. Enter. Okay. So when we go to the little green square on the right down corner there, double click, bam. It does that for each one of them automatically. And then we want the sum. So we just go to auto sum. Okay. Auto sum, pap, sum, enter, boom. And here it is. Copy and paste. Control C, Control V. Okay. So this now is old school, that little table there. You see, can create a table. Here it is, headed x squared. So that was, you know, before time. Okay, but now we're on a new level now. So delete this, Control V, right? And then basically bring this up a little bit. Okay, then raise our little rectangle because I want to make use of that little space that's there. With the tables, Excel will not, Microsoft will give me difficulties to type there, you know, because of the table. So you can just go and type in an text box, sorry, Control C, go by this there, Control V, bring this there, increase in size. All right, therefore, variance is equal to 77676. 77676 divided by 12, subtract the mean squared. Okay, the mean is 78.83 raised to the power of 2. Okay, or we can use equations and script and superscript raised to the power of 2. Okay, this you can type that straight in your calculator. Okay, get accustomed to type as is straight off in your calculator. There it is. Okay, 77676 divided by 12 minus 78.83 squared. As this is written, you can put it in your calculator. You can use brackets. You can put this in a bracket and then close this in a bracket. And they give you your answer one time for the variance. Okay, 258.83. Okay, there it is, 258.83. So coincidentally, we are getting the same answer, 258.831. Sometimes you might get slightly different answers, 258.831. But in this case, we're getting this exact same answer, and the standard deviation is the square root of the variance. Okay, so that is equal in percentages. So therefore, the average dispersion, the average spread or difference between the 12 scores is about 16%, you know, give and take, yes? Standard deviation for raw values using the second method.